Maths 6 IT Academy. In this video, I am going to discuss about the co-ordinate geometry, and our subtopic is centers of the triangles. Different centers of the triangle means centroid, orthocenter, circumcenter, incenter, etc. So that we will discuss everything briefly in detail with the proof. Okay. So first of all, let us discuss about the centroid. So centroid means when you are taking a triangle ABC and you have to draw the median. So what is median means? The line segment from the vertex to the opposite side and which divides the opposite sides into two segments, two equal segments is called median and identified as D. So like this we can draw three medians in a triangle, and these three medians will intersect at one point. Let it be, these are E and F, and these three medians are intersecting at one point, and that point you can take it as G, and this is only called centroid. That means point of intersection of the medians of a triangle is centroid. Simple. Okay. Point of concurrency of the medians is called centroid. That also we can give, or simply point of intersections of the median is called the centroid. Now here you see again, I will draw the diagram here. ABC, D, E, F, okay, and this is G. So now what I am doing means here, I am extending the side AD up to some point, suppose H, such that AG is equal to GH. Okay, I am extending the AD side up to some point AH such that AG is equal to GH. So join this BH and CH. Okay, here we have taken AG is equal to GH. This is important point here. So when you look at the diagram here, AH is the line segment and AG is equal to GH, that means G is the midpoint and F is the midpoint of the side AB. So when you take triangle ABH, in triangle ABH, F and G are the midpoints of AB and AH respectively. AB and AH respectively. So when we have two midpoints, the line segment joining the two midpoints of a sides of the triangle, we can apply the midpoint theorem. By the midpoint theorem, we can say that this FG is parallel to BH. That means FG is parallel to BH by midpoint theorem. In the similar manner, here G is the midpoint and E is the midpoint of the AC. So what? According to the midpoint theorem in the triangle ACH, in triangle ACH, what we can say means here GE is parallel to HC. GE is parallel to HC. That means when you see the BECH quadrilateral, BECH quadrilateral, here this is parallel to FG, hence FC is parallel to BH, and BE is parallel to HC. So here I am writing. So in quadrilateral BFCH, what we have is BH is parallel to FG. BH is parallel to FG in the sense FC we can write. So FC. And what we have here, GE is parallel to HC. So GE is parallel means we can write BE. BE is parallel to HC. So in a quadrilateral, opposite sides are parallel. Hence, this is what? Parallelogram. So it is a parallelogram in the sense diagonals bisect each other. So when diagonals are bisecting each other, what we can say means here, BD of course equal to BC because D is a midpoint. And of course by the what we can say means here it is parallelogram, so we can say diagonals bisect each other. So here GD is equal to DH again because diagonals are bisect each other. Okay, so what we can say means here so what here AG, so here AD, AG is equal to GH, that we have AG is equal to GH by the construction. And from the diagram AG is equal to GH means here GD plus DH. Okay, so now as we know here DG and DH are equal, so I am writing this is G. So here 2 times of GD. So here AG by GD is equal to 2 by 1. So that means what we can say here, AG by GD is equal to 2:1 means here G is a centroid, therefore centroid divides the median in 2:1 ratio. So this is the reason we will say normally the centroid divides the median in the ratio of 2:1. Okay. So here no need to confuse about the taking quadrilateral here. You can take BFCH or BGCH or BECH. Whatever you take, no problem. Ultimately the concept is to prove the diagonals are bisect each other. When you are taking this BFCH, what is happening is that this FG is involving here. So here without involving FG also we can say that GC is parallel to BH. And even here GE is parallel to HC, that we have got. So by that we can say that BG is parallel to HC. So simply you can take BGEH quadrilateral and you can prove that this is a parallelogram and hence diagonals bisect each other and you will get the relation of this. Okay, so there is no problem there. So now this is a very important key point here. Okay, so from this point we come to know that centroid divides the median in the ratio of 2:1. Okay, so now we will find the centroid when we know the 3 vertices. Okay, so here I am taking a triangle ABC and whose vertices are x1 comma y1 and x2 comma y2 and here x3 comma y3. Okay, so now here I am taking these a midpoint here. So D is a midpoint means according to the midpoint formula what we can write means that D is equals to x2 plus x3 by 2 and y2 plus y3 by 2, this we can write. And also here what we know about the median. So here we know the relation between the median and also centroid. So as we know that centroid divides the median in the ratio of 2:1. So here to make it clear, I am writing again, I am drawing a diagram for the line segment AD. So here AD is a line segment and G is a centroid and which is dividing AD in the ratio of 2:1, and here we know the vertices of A and also D and we have to find the centroid G. Here we know the ratio also. So what we have to do means we have to apply the section formula to get the value of Z here. So here A is x1 comma y1 and G we can take it as x comma y, and D already we have found here that x2 plus x3 by 2 comma y2 plus y3 by 2. Okay. So now apply the section formula. By section formula, what we have here, mx2 means here 2 into this term. So that means here 2 into x2 plus x3 by 2 plus 1 into this x1. So x1 by m plus n. M plus n means here 2 plus 1. Comma, similarly the same thing, 2 into the y terms. So here 2 into y2 plus y3 by 2 plus 1 into y1. So y1 divided by 2 plus 1. So that means here 2 will get cancelled and you will get what here? In the numerator we have x1 plus x2 plus x3 by 3, and here y1 plus y2 plus y3 by 3. Okay. So this is the formula to find the centroid of a triangle. Okay. G is equals to x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Okay. So important. So that's all about the centroid. So next we will see incenter. Okay. So incenter means we have to know about the internal angle bisector. Okay. So we will discuss now. So here I am taking a triangle. Okay, ABC. I am giving the name for this. Okay. So now here internal angle bisector means a line segment which divides the angle into two equal parts is called internal angle bisector or angle bisector simply. Here we are bisecting internal angle, so we can call it as internal angle bisector. Okay. So internal angle bisector, that means here this is total angle is A and we are bisecting it, so this is A by 2 and this is also what? A by 2 here. Okay. And this internal angle bisector is intersecting the opposite side BC at point D. Okay. So similarly here we can draw the internal angle bisector for the remaining angles of the triangle ABC, that is D and also C. So these three internal angle bisectors will intersect at one point, that is only incenter. So what we can say means point of intersection of internal angle bisectors. Internal angle bisectors is called incenter. Okay. So now how to find the incenter? So if you want to know the formula, means the derivation of the formula of the incenter, we must have to know what is internal angle bisector, means internal angle bisector theorem. So that I will discuss first, and after that we will go to the proof of this. Okay. So now here I am taking a triangle ABC. Okay. Now I am dividing the. Okay. I need more space. So here. Okay. ABC triangle. Okay. So now I am dividing this angle A into two equal parts. That means these two are equal to A by 2 and this is A. Okay. So now what we have to do means just draw the parallel line which is parallel to the AD from the vertex C. Okay. We can say draw a ray. Suppose you can take CX and extend AB which intersect the extended ray or the ray at some point, let it be some E. Okay. We have drawn a parallel line which is parallel to AD, or we have drawn a ray from the vertex C which is parallel to AD. Okay. So here AC is a transversal. So alternate interior angles are equal. So hence it is equals to A by 2. Alternate interior angles. Okay, even this theorem, this is also one of the important theorem. Okay, alternate interior angles are equal. So by that we can say these two angles are equal. So this is A by 2. Hence this is also A by 2. Okay. So now here these two are parallel lines. So corresponding angles are also equal. Corresponding angles are equal. That means here this is the corresponding angle. This is the corresponding angle to this. So this angle is A by 2. So this angle is also what? It is equals to A by 2. That means what? Corresponding angles are equal. Okay. So in the triangle AEC, when you observe, these two angles are equal. A by 2, A by 2 both are equal. That means the angles which are opposite to equal sides are equal, or the sides which are opposite to equal angles are equal. Both vice versa possible. So these two are the angles which are equal. So hence opposite sides are also equal. Hence we can say that AC is equal to AE. Okay. And also here in triangle BCE, we have AD is parallel to CE. AD parallel to CE. So by BPD theorem, basic proportionality theorem, what we can write? The corresponding sides, the sides are in the same ratio, the remaining sides. BPD theorem statement I am telling now. When you draw a line which is parallel to the any one side of a triangle, which intersect the remaining sides at distinct points, and that divides the remaining sides in the same ratio, that is the BPD theorem. Okay. So which divides this AD divides the remaining two sides, because here AD is parallel to CE, one side. The remaining sides means here BC and also BE. These two sides are in the same ratio, same proportion. That means BD by BC is equal to BA by AE. This is from BPD theorem. Now actually what we have here, BD by DC. Initially we have considered only triangle ABC, and this is our construction. So we have to do including only in the triangle ABC all these operations. So here AB is also which is a side of the triangle ABC, but here AE is external side, but we know that here AE is equal to AC. So simply we can replace and we can say BD by DC is equal to BA by AC. BD by DC is equal to BA by AC. So what is the statement of this internal angle bisector theorem? Means when you bisect the internal angle, that internal angle bisector will divide the opposite side into two line segments. Okay, AD is the internal angle bisector. This is dividing opposite side into two segments, BD and DC. These sides are proportional to remaining two sides. Remaining two sides means here AB and also AC. That means BD by DC is equal to BA by AC. Okay, here order is very important. Here I am starting with B. So BD by DC is equal to, again you have to start from B only, BA by AC. Here you cannot write BD by DC is equal to CA by AB. This is wrong. Okay, so with proof I have explained. Hope you understood. Okay, so this is the internal angle bisector. Okay, so now we are going to apply this concept to find what is I. Okay, so that we will see now. Okay, so for any triangle when you are taking, ABC, will always denote the sides, length of the sides with the small letters. So here what is the length of the side BC means it is opposite to vertex A. So we will denote this is A and this is B and this is C and this is same for all the triangle all the time. So now intertriangle bisector we have to do. So here bisect it. So these internal angle bisectors are intersecting at one point that we are taking I. Okay. So now here what? Here AD is the internal angle bisector. AD is the internal angle bisector of triangle ABC. So AD internal angle bisector means from internal angle bisector theorem what we can say, BD by DC is equal to BA by AC. So BD by DC is equal to what? BA by AC. So what is BA? BA value is equal to C, small c, and AC value is equal to what? B. Okay. So that means what? BD by DC means here D dividing BC in the ratio of C is to B. That we can say from this. So D, once again here we can take this is B and this is C and this is D. D is dividing BC in the ratio of C is to B. Here when you are taking A is x1 comma y1 and B x2 comma y2 and C x3 comma y3, and simply you can find the D here by using the section formula, because here we know the vertex of B and also C, and we know in which ratio the points of D is dividing BC. Okay, so by applying the section formula we can find D, and that is nothing but C into x3 plus B into x2 by B plus C, comma B by 3, sorry C by 3 plus B by 2 by B plus C. This is the vertex D after applying the section formula. So now here clearly observe one thing, because here we are going to find the value of BD here in terms of ABC. Okay, so here as we know BD by DC is equal to C by BD. We can write that by taking reciprocal. We can write DC by BD is equals to B by C. Now add 1 on both sides. After adding both sides 1, what do we get means here? BC by DC dB plus 1 is equals to B by C plus 1. So here BC plus BD by BD is equals to B plus C plus C. So BC plus BD, BC plus, sorry, DC not here, sorry, here DC plus BD, DC plus BD means here we can write this is equals to BC, BC by BD is equals to B plus C by C, and BC is what? BC is the total line segment and which is equal to A. So here A by BD is equals to B plus C by C. Okay. So now from this we can find the value of BD in terms of ABC. BD we can find by taking this into that side, and hence BD is equals to AC by B plus C. This is the BD. Okay. So now what we know here, I am leaving this because this I don't want right now. Okay. So now BD value given in terms of ABC. Okay, and here if you observe BE is internal angle bisector of the angle B in the triangle ABC. So again we can apply internal angle bisector theorem. So here when you are taking AD is the base, AD is the base means here in the triangle ABD I am applying, in triangle ABD I am applying angle bisector theorem, internal angle bisector theorem by internal angle bisector theorem. So what we can say here, the opposite side to this BI is this DA. So which divides, so which is in the same proportion to the remaining two sides. So remaining two sides means here what? Here DI, this internal angle bisector dividing the opposite side into two equal segments. Sorry, two segments, not equal. Two segments, and which are in the same ratio of the remaining two sides. Means DI by IA is equal to DB by BA. Okay, so this we can say. So here DI by IA is equal to DB. What is DB? DB means your VD value we have found in terms of ABC. So DB is equals to AC by B plus C, and divided by BA. BA is what here? BA is equal to C. So C. So when you simplify this DI by IA, what will get means here? Here CC will get cancelled. So here A by B plus C. So DI is A and IA is B plus C. To understand, I am drawing the diagram here. Okay. So here let me write here. Okay. So this is, now this I want AD. So here this is A and this is D. Okay, and this is I. And from this what we have? DI by IA. So DI by IA. So DI is equals to A and this IA or AI is B plus C. Okay. Now A is what? X1 comma Y1. And D is what? Just now I have cleaned. D is the bisection formula we have found the D value, that is equals to what here means CX3. Let me write D again. Here D divides BC in the ratio of C is to B. So bisection formula D is equal to CX3 plus BX2 by B plus C, comma CY3 plus BY2 by B plus C. This is the vertex D. Same thing you can write here, comma CY3 plus BY2 by B plus C. Okay. Now we know the two vertices and we know in which ratio I is dividing AD. So we can find I by applying section formula again. So again if you want to apply what? Here I of x comma y is equal to what here? B plus C into the x coordinate of the second point. B plus C into CX3 plus BX2 by B plus C. Okay, plus CX2 plus AX1 by M plus N. M plus N means here what? B plus C plus K. Okay, comma B plus C into the second. B plus C into the second coordinate means y coordinate is the second point, that is CY3 plus BY2 by B plus C plus this N into y coordinate here. So AY1. Okay. So now here B plus C cancel. Okay. So now what we have here means AX1 plus BX2 plus CX3 by A plus B plus C. Okay. So here we can write AX1 plus BX2 plus CX3 by A plus B plus C, comma ay1 plus by2 plus cy3 by a plus b plus c. Okay, so this is the formula of in-center. So anyway, this is the proof of the in-center. Okay, so it seems very lengthy because even I have explained with the help of the angle bisecting theorem, that also with the proof. So if you concentrate, it is not difficult. So the thing is, we have to find first b vertex, next I. Before finding I, we have to find the BD value in terms of ABC, and after using the section formula, you will get the vertex I, and that is only gives the in-center. Okay, so anyway, in-center is denoted by I of x comma y is equal to ax1 plus bx2 plus cx3 by a plus b plus c comma a by 1 plus b by 2 plus c by 3 by a plus b plus c. So this is the formula, right? So next x center we have. So x center is the next important find here. So here x center. So what is the x center means? Here I am taking a triangle ABC. Okay. So now here x center means here I want two external angles. So to get two external angles, here we can extend the sides AB and also AC. Now bisect this external angle B and also angle C. Okay, and the internal bisector which is opposite to the vertex, opposite to the base BC. Internal angle bisector. Okay, so these three bisectors, angle bisectors are intersecting at one point, and we can say this is the x center. Okay, so here why we are denoting this is with I1. I1 means here which is opposite to vertex A. So only I1. If it is opposite to vertex B, then it is I2. If it is opposite to vertex C, then it is I3. It will come like this side. So anyway, what is the x center means? The point of intersection of two external angle bisectors and one internal angle bisector is the x center, and which is denoted by I1. So simply here I will give the formula for I1. I1 of x comma y, which is equals to here only one internal angle is involving here. So give the minus sign for the first term. So minus ax1 plus bx2 plus cx3 by minus a plus b plus c. Actually what we have to do means here ax1 minus bx2 minus cx3 by a minus b minus c will come. But after taking minus common, you will get the same. Okay, so why we are writing this means to remember the formula easily we will do this. Okay, so originally what you will get means, again I am telling, ax1 minus bx2 minus cx3 divided by a minus b minus c you will get, but we are taking minus common and hence the result is this. So comma minus a y1 plus b y2 plus c y3 y minus a plus b plus c. Okay, so next I2 of x comma y. I2 of x comma y means now which is opposite to the angle B or the vertex B. So now here we can extend this like this, and here we can form. Okay, so this is I2. Okay, so now I2 of x comma y is equal to what? Here ax1 minus bx2 plus cx3 by a minus b plus c comma here ay1 minus by2 plus cy3 by a minus b plus c. And next x center I3 of x comma y, and I3 means which is opposite to the vertex A. So that means here you have to extend the sides AC and also BC here, and external angle bisectors are the external angles A and also B, and internal angle bisector of the angle C. So this is called I3. Okay. So I3 is equals to ax1 plus bx2 minus cx3 by a plus b minus c comma ay1 plus by2 minus cy3 by a plus b minus c. Okay, so these are the formulas to find the x centers which are with the respectively opposite vertex differently. Okay, so that's all about the x center.